Difference between Docker and virtual machines (VMs). Both Docker and virtual machines (VMs) are used to create isolated environments for running applications, but they achieve this in fundamentally different ways. Here's a detailed comparison. Architecture. Docker uses containerization technology. Containers share the host operating system's kernel, making them lightweight and fast. Each container runs as an isolated process in user space. Containers package only the application and its dependencies, not the entire OS. Virtual machines, VMs, use hardware-level virtualization. Each VM runs a full guest operating system on top of the host system. VMs rely on a hypervisor, like VMware, VirtualBox, or Hyper-V, to manage and allocate hardware resources. VMs are more resource-intensive because they include the entire OS. Performance and resource usage. Docker. Faster startup time. Containers can start in seconds. Lightweight because they share the host OS kernel. Less resource-intensive, smaller size, lower memory, and CPU usage. VMs. Slower startup time. Booting a full OS can take minutes. Heavyweight due to running separate OS instances. Require more memory, CPU, and storage. Portability. Docker. Containers are highly portable across different environments: development, testing, production. Run consistently on any system that supports Docker, Linux, Windows, Mac OS. Ideal for microservices architecture and cloud-native applications. VMs. Less portable because of OS dependencies and larger image sizes. VM images can be moved but are larger and slower to transfer. Better suited for running legacy applications or when full OS isolation is required. Isolation and security. Docker provides process-level isolation. Containers share the host OS kernel, which can pose security risks if vulnerabilities exist. Less isolated compared to VMs, but improving with tools like rootless containers and namespaces. VMs offer stronger isolation because each VM runs a separate OS. Better for multi-tenant environments where full isolation is critical. Less susceptible to kernel-level vulnerabilities. Use cases. Docker. Best for microservices, cloud-native applications, and CI/CD pipelines. Ideal when you need quick deployment, scalability, and efficient resource usage. Commonly used in development for consistent environments across teams. VMs. Suitable for running multiple OS environments on the same hardware. Great for legacy applications that require specific OS configurations. Used in enterprise IT infrastructure where strong isolation is needed. Storage and size. Docker. Containers are smaller in size, typically MBs. Docker images are layered and reusable, reducing redundancy. VMs. VMs are large, typically GBs, because they contain the full OS. Each VM requires dedicated storage for the OS, even if multiple VMs run the same OS. Management tools. Docker. Managed using tools like Docker CLI, Docker Compose, and Kubernetes for orchestration. Supports automated scaling and rolling updates in container orchestration systems. VMs. Managed using hypervisors like VMware, VirtualBox, Hyper-V, or KVM. Snapshot and backup features for maintaining VM states. Key differences table. Aspect Docker, containers, virtual machines, VMs. Architecture shares host OS kernel, process-level isolation, runs full OS with hardware virtualization. Startup time fast, seconds, slow, minutes. Resource usage lightweight, shares kernel, smaller size. Heavyweight, full OS, higher resource use. Portability, highly portable across systems, less portable, larger image sizes. Isolation weaker, shared OS kernel, strong, separate OS for each VM. Security moderate, depends on OS kernel, strong, full OS isolation. Use cases microservices, cloud-native, CI/CD legacy apps, full OS environments. Storage size smaller, MBs, larger, GBs. Conclusion: Docker is perfect for lightweight, scalable applications that need to run consistently across environments. It excels in cloud-native development and microservices. Virtual machines are better suited for scenarios requiring full OS isolation, running multiple OS types on one host, or supporting legacy systems. In many modern architectures, Docker and VMs are used together. VMs provide the infrastructure, and Docker runs lightweight, isolated applications on top of them. Rocket